By the way, I'm sharing this collab notebook that I'm going to be using for this session. Please feel free to access it and then run it on your own and or follow along um, with me, as I explain things. Okay, just one more minute and then we'll start. Yes, this will work with any GPU that is available on Colab. So T4 will be fine, A100 will be fine, anything works. Okay, let's get started. Before I start, I'd like to let you know that this is a bit of a hands-on tutorial kind of thing. I'll just be going through this notebook, just going to explain a bunch of things about IndicBART and the Indic energy tasks that we have. So I'll talk about IndicBART works, how it can be fine-tuned, and how IndicBART was pre-trained very deeply, so that even if you don't know much about what IndicBART is, and even if you don't have, if you leave the session halfway, you'll still be able to, follow along and understand what the internals are and the internal mechanics are. And please feel free to stop me at any point of time during this session because yeah, since it'll be very hard for people to keep track of where you wouldn't understand. Just stop me and ask me specific questions. These can be questions about IndicBART. This can be questions about the code. Anything is fine. Just let me know. Okay, so let's get started. Okay, so just a quick show of hands. Maybe has anyone among you ever used IndicBART or you know ever tried to train your own BART model in the past? I guess not. It seems. Oh, okay, Nikhil has tried it. But it seems a vast majority of you haven't. Okay, that's totally fine. So as you very well know, right, we are in this era of pre-trained models where we assume that the data available for downstream tasks is not readily available. And because it's not readily available, what we would definitely like to do is leverage monolingual data, the monolingual data being relatively abundantly available compared to, let's say, task-specific data. So what we'd like to do is take monolingual data and then incorporate certain kind of information into models. And then once we've incorporated a lot of information from monolingual data, we assume that even if we have a small amount of downstream data or even no downstream data, we should be able to enable tasks, enable a model to perform tasks in for downstream tasks for a given language. So back in around, I guess, 2020, there was this model called as BART, which was created. So BART is essentially an encoder-decoder pre-trained model for English. It came in a variety of sizes and variety of capacities. But essentially, it was the first pre-trained model for encoder-decoder pre-trained model for English. And they showed that because of the pre-training, what happened was that you could use only a small amount of fine-tuning data, and you could get a pretty high quality downstream task performance. So that did exist for English, but the problem is that nobody had actually released any kind of notebook on how to do any kind of BART pre-training. So in 2021, me and some researchers from AI4Bharat, we got together and we thought like, okay, things exist for English, but what about for Indian languages? And at that point of time, we were like, okay, how do we get started? And since I was very interested in this, I took it up and I thought like, okay, let me build this from the ground up. So it ended up with me making an entire toolkit for machine neural machine translation, as well as for pre-training these kind of encoder decoder models. And then because of that, we ended up with IndicBART. And then the follow-up work was the Indic NLG benchmark. And this notebook essentially covers certain critical aspects of it. So let's first of all get connected to a GPU instance. I'm hoping that I get a GPU. If not, this thing is going to be very embarrassing. Okay, all right. So it seems I might be getting, okay, I got a T4 GPU. And now this notebook will work even if you have a T4 GPU, A100 GPU, it doesn't matter. A100 is faster, but T4 will work fine. So first things first, we do some standard installation of the different libraries. So we have transformers, we have sentence piece, and then we have NumPy. All of these are the least minimum requirements. And transformers, one thing you'll notice is that this IndicBART implementation, although it was implemented in a very old version of transformers, it will still perfectly work with even the most latest iterations of transformers. So it's very much compatible even with old versions of transformers, even the latest one, it should be perfectly fine. One of the things that I was kind of hoping would happen is at some point of time, I want to get around to training a newer version of IndicBART supporting 22 languages, and then with these, support longer contexts and so on and so forth. So I'm hoping I'll get around to it. I'm not sure when I'll get around to it, but that day should be sooner rather than later. And while this, libraries are being installed in the background, I just wanted to give you an overall where I talk the token, talk about Devanagari scripts. I wanted to talk about how the abilities of the what happens you do fine tuning, what happens when you do fine tuning for machine translation, what happens when you do fine tuning for summarization, how to save models, how to load models, and most importantly, how to actually pre-train this IndicBART model. So I'll go through all of these things. There are a bunch of different things, and I think it'll take about maybe 40-45 minutes, 1 hour. So hopefully you get a fair idea of at least how to use this notebook, but more specifically on how to be able to do pre-training of your own. This notebook could pretty much be used to do this kind of pre-training. Okay, so the libraries were installed. The next part, and this is very important for IndicBART, is that we need to have the Indic NLP library installed, because the Indic NLP library allows you to do Indic-specific tokenization, transliteration, romanization, and so on and so forth. So this is one of the things that we will very much use for Indian languages, because in Indian languages, you know that it's a phonetic script, and essentially you can convert one script to another script and still retain the same pronunciation without any issues. So this is pretty much one important aspect of this IndicBART working. So now that all the libraries and everything has been installed, let's directly jump into the IndicBART model. Just 1 second. Can I just maybe have, um, I wanted to have a pointer, which I don't seem to have. I don't have a pointer for some reason. I thought I'd have one. Okay, never mind, never mind. It's totally fine. Okay, so let's work with IndicBART. So we have the tokenizer and then the MBART model for conditional generation. So IndicBART was built on the MBART model, but the tokenizer it uses rides on top of the Albert tokenizer, with the exception that the Albert tokenizer was designed for English, but I've replaced the internal parts so that it can handle my own custom made sentence piece tokenizer for 12 Indian languages plus English. So now that the model has been loaded, it's time to start playing around with some basic configurations to make sure that the model knows what beginning of sentence and end of sentence tokens are. So how does this IndicBART tokenizer look like? So suppose you have an input sentence, I'm a boy, and the output sentence being Main ek ladka hu, which is in Hindi. Let's see what the model sees when you do this kind of tokenization. So you can see that the sentence "I'm a boy" has been tokenized into I am a boy, 4 tokens. Presumably because all these 4 tokens are very common tokens and they will have been seen by the tokenizer during pre-training, and therefore each token is not further split into smaller units. And then you have the tensor representation, which is just the vocabulary index. Then when it comes to Hindi, which is Maik Ladka Hu, again, these are very common words, and therefore each word is its own individual token, and it is split into 4 tokens. And again, the index vocabulary indices representing the tensor. So what happens when you use non-Devanagari and non-Roman script languages? So for example, this is I keep on mixing whether this is Tamil or Telugu. It's one of these two languages. I'm very sorry for not recognizing it. So what happens when you have an input sentence in one South Indian language and pass it through the tokenizer and ask it to split this sentence? So how does it work? Well, you can see that it's actually doing a very, very, very bad job of it. It's kind of splitting it very weirdly. You don't see any kind of understandable or noticeable subword units, and the split version is pretty long as well. So why is this happening? It's because actually when IndicBART was trained to not work with a variety of scripts, but with only 2 scripts. The first script being Roman script, which is English, and the second script being Devanagari script. So what we had done was we had converted the script of every other Indian language into Devanagari. And why we did that was so that, because Indian languages are very similar to each other, by converting everything to Devanagari, we would increase the chances that some kind of subwords or root words or basic fundamental words would be shared across languages. And when you have sharing across languages, it's possible to transfer knowledge from a high resource language like Hindi to a low resource language like, let's say, Odia or to Assamese. And in the IndicBART paper, we have some results showing that, okay, this script shared model or a unified script model works much better than a model with separate scripts for different languages. So the first thing that you need to do is transliterate, let's say this, okay, it is a Tamil sentence into Devanagari script. So transliterate from TA to HI. And then once you do that, what does it look like? Okay, so originally the Tamil sentence looked like this. And then once you have the Tamil sentence converted to Devanagari, it looks pretty much like this. Actually, now that I realize it, I would like to zoom in a little bit. Okay, this is much better. So this is the Devanagari equivalent of the Tamil sentence. And then if you pass it to the tokenizer, it's doing a pretty good job of segmenting it. And it makes sense because the tokenizer itself was trained with all the data converted to Devanagari script or in English. So this is the reason why the segmentation looks much better. Although this is actually a Tamil sentence, just that it's written in Devanagari. That's all. If you read it, it will more or less sound like Tamil, as far as I understand. So for the rest of the notebook, I'm focusing more on Hindi examples, but you can feel free to experiment with whatever language you want when you try it on your own. So let's see what the IndicBART model can actually do, right? So you have an input sentence, it says I'm a boy, then you pass it to the tokenizer, and then you make the model generate an output for the input. So the input was I'm a boy, and you are going to ask it to generate an output in Hindi. Just the IndicBART model. It hasn't been fine-tuned yet. Let's see what happens. So what happens is if your input is I am a boy, your output also ends up becoming I am a boy. So why is that? Is there something wrong with passing an input as a, let's say, English sentence and asking it to generate Hindi? Maybe, maybe not. Let's see what happens with Hindi as an input. Maybe it might work better. Well, again, in Hindi, even though I have passed the sentence as Maik Ladka Hu and I've asked it to generate some output, it just copies what it is. So essentially, it isn't translating, it isn't doing any kind of special performance. So does this model just know how to copy? Well, technically, yes, but it's much more deeper than that. The thing is, IndicBART was not fine-tuned to do anything. It wasn't fine-tuned to do translation. It wasn't fine-tuned to do summarization. So it can't do anything. You'll have to fine-tune it. But what it can do is something very simple and very interesting. So what you could do is you you could insert masks inside your sentence. So you can say, "मैं एक mask हूँ," and then this IndicBART model will generate something in the place of mask. So let's just look at what it does. If I ask the model, if I give the input as "my ek mask who," then its segmented or tokenized equivalent is this. And you can see that the word mask is tokenized properly. And then there is an input tensor version and then the model output. And the model output looks like this. It says "my ek kalakar hu." So the word mask, whatever was corresponding to mask, the model predicted that mask is best substituted as kalakar. And this is essentially what IndicBART was pre-trained to do. It was pre-trained to produce words as a replacement for mask tokens. So in fact, it could produce not just one word, but it could produce multiple words as a generation for a particular token. So for example, right? So you could, if you just say "my mask," let's see what happens. So it says "मैं and it just doesn't know what to do. So depending on what kind of input you put in, the model will generate something interesting. So if you say something like "my mask," let's say two masks, then what happens? And then it still doesn't know what to do, and it generates "मैं हूँ" with a end of sentence marker. If I put one more mask, then it says "मैं जानता हूँ." So essentially, "मैं mask" generates "मैं जानता हूँ." So essentially, the model is able to predict let's say, words in the place of mask tokens. So let me just undo this so that people don't have difficulties. Okay, cool. All right. So now it can predict mask words. Can it give multiple replacements for mask words? Because right now I'm asking only for one replacement, but what alternatives can it generate? So you can see that it can generate words like "मैं जानता हूँ," "मैं हूँ," "मैं नहीं हूँ," "मैं नहीं." So it has a lot of varieties, and depending on how what kind of input you give in, it is just going to generate different outputs. So let us try one more time, and one more time, if you run this, you will see that it generates "मैं एक कलाकार हूँ," "मैं एक पत्रकार हूँ," "मैं एक महिला हूँ," "मैं एक इंसान हूँ." And essentially, whenever you have that mask, it can generate very most probable or most likely or most viable options to replace that mask token. So what about for English? Can it do this for English as well? Well, in truth, it can. So for example, if your English sentence was "I am a mask," then what it is doing is it produces the word "woman" in place of it, student, doctor, politician, everything. So it generates very viable sentences or natural sentences, so very likely sentences by replacing mask or predicting something in place of mask. So now you know that IndicBART is a pre-trained model which has the ability to predict words in the place of masked out content. So then, how do I make IndicBART do translation? Because at the end of the day, I want to use this model for a downstream task. So how do I do that? Well, you fine tune it on parallel data. And what is parallel data? Parallel data is pretty much like this. I am a boy. It has its Hindi translation as "मैं एक लड़का हूँ." I love food. मुझे खाना पसंद है, and so on and so forth. If you want summarization, then your data is going to be something like, there was a child, she liked food, she decided to learn to make food, she became a world-class chef, she won an award. And the summary is something like, a child learned cooking and won an award. A bit simplified, but you get the gist. So you just need pairs of input output data corresponding to your task, and it's very straightforward. For now, let's try with translation. So for translation, I'm getting some data from Moses, and specifically, I'm getting the data for the TED task, and this is an English Hindi parallel corpus. So I'm just going to do a small amount of experimentation, and you can see that the data that I've downloaded, it has about 47,633 parallel sentences for English and for Hindi. And now that we have this data, it's time to start training our model. So I'm not going to go through specific details of how this training is done, but essentially there are three major or four major components. One is a corpus iterator, so something that goes over the corpus. One which generates batches over the corpus. So if you have, let's say, 5,000 sentences and your batch size is, let's say, 1,000, you'll have five batches. In practice, batches are never that large unless you do some kind of trickery. But yeah, you'll have smaller batches, like maybe 50 sentences or 100 sentences. And this code that I've written over here is essentially responsible for generating batches. And then one important component is to compute a loss on the let's say the predicted tokens versus the actual tokens. So this essentially implements what is called as the label smooth NLL loss. Now, because there is much to cover, I cannot go too much in depth about how this is done. But maybe if we have time later, I'll talk about it specifically. But this is a very standard machine learning thing, which is label smooth NLL loss. And the other thing is you have to create an optimizer and you have to create a scheduler. So in our case, we have the Adam W optimizer and a linear scheduler with warm-up. So the linear scheduler with warm-up essentially warms up your learning rate up to a peak and then decays the learning rate close to zero. And this is again very standard procedure to create an optimizer, to list a number of parameters for the optimizer, to determine what are the parameters to be optimized, and then essentially creating the optimizer and creating the scheduler. So in this case, what I'm doing is for the uh, Adam optimizer, I'm setting a peak learning rate of 10 to the power minus 3, and I'm creating a scheduler such that I have a maximum 4,000 training steps, and the warm up will take place around 200 steps. So when my training reaches 200 steps, it will reach a peak learning rate of 0.01. After that, it will start decaying to zero at 4,000 steps. So let's get this done. Okay. And now let's train this model first for 500 iterations and see what we can get. Now, training this model for 500 iterations is going to take a bit of time. So we're going to try to train as much as possible, and we'll see how this model trains. So initially, right? You're just taking the IndicBART model, and before even training something, we have an evaluation phase. I've given it 3 sentences. I'm a boy, I love food, and let's take a break. And I'm asking the model to translate from English to Hindi. India at its match, whenever it was not fine-tuned, it just doesn't know what to do. So it just copies the input as the output. So I'm a boy becomes I'm a boy. I love food becomes I love food, and let's take a break becomes let's take a break. So nothing is changing. And the loss initially is around 8.05. So this loss is pretty much, let's say, a very much expected amount of loss at an initial stage of pre-training, at the initial stage of fine-tuning. Because again, let's face it, the model has no idea what machine translation looks like. It only knows how to predict content corresponding to tokens. But now you've seen that after 100 steps, the model has reached a loss of 4.93. In other words, your model is learned, but it's still, for I, the output is still I'm a boy, and so on for the other sentences. It is still copying content as it is. So why is it not copying anything? It's not. Why is it not translating? Because even though the loss has reduced, the model still needs a little bit of time to actually understand the task. So currently, it is adjusting its probabilities. It is adjusting its internal representations to learn the translation task, but it still hasn't reached the tipping point of its learning to actually start translating. But the moment the model reaches, let's say, step 200 or step 300, suddenly you'll see the model start behaving like a translation system. Oh, look at this. Look at this. After 200 iterations, I am a boy finally is being translated to Maek Ladka. And it's a very bad translation. It should be Maek Ladka Hu. It's missing that Hu word. But at the very least, the model has kind of reached to a point where it can begin producing some very, very, very basic translations. Now, you should understand this and keep this in mind, is it can produce translations just after 200 iterations of training because the model already has learned a lot of monolingual knowledge by during pre-training stage. But if it hadn't seen a lot of pre-training data, it would need a lot more iterations and a lot more data before it could even produce any kind of sensible content. It would actually generate garbage. It might just generate some garbage Hindi tokens even after 200 iterations. But because it has pre-trained, it will generate something. Okay, so after 300 steps, let's see what has happened. So after 300 iterations of training, uh, badly translate to, but again, being badly translated by Khana, and the let's take a break is kind of code mixed over here. Let egg break. So you can see that it is beginning to learn. It is beginning to catch the basic concepts of what translation is. And then if we wait for another, let's say 30 seconds to 40 seconds, you'll see that the model will start actually tipping over to the point and start producing translations pure in the target language. So the good news is after 300 iterations or 300 batches, uh, the model has begun to recognize that it no longer should be copying content or predicting masked content, but it should actually be performing translation. So after 400 iterations, again, the first translation is still not that good, but I love food, it becomes मैं खाना पसंद करती हूँ, which is more or less correct. It could have been, yeah, I mean, this is a reasonable translation. And then let's take a break is being translated as अब समय निकालो. So ab samay nikalo is again not a very good translation, but I mean it's totally fine. So let's wait for the final 500 steps of translation of training finish, and then we will play with this a little bit further. So any questions so far?
Yeah, you may want to check the chat.
Yeah, is there some stuff on chat?
Yeah.
Oh, there is a lot of questions on chat. Okay, I see
No,
this
no.
one. Sorry.
If you want, I can. There was one specific question about laghu versus dirgha matras, like u versus dirgha u, that
Yes.
is translated for Malayalam, Tamil, these
Mm-hmm.
languages in Devanagari. How
Mm-hmm.
does that happen? Is that one question, and another question was about the slash to hi and to ae and those special type
Okay, okay.
things.
Oh, there are actually a ton of questions over here. For some reason I have no idea why I kept my this chat separate. Okay, actually let me move this over here. Okay, so I'll just go through the questions one by one. So the first question is from Ashwan. So the translation is is just to represent the exact words in Tamil in Devanagari. It's not translation, it's transliteration, but yes, we just want a Devanagari equivalent of the original language. Then the question was, why was there a dot below no? Have not seen that in Devanagari before. So that is possibly happening because the transliteration rules are handled in a very rule-based format, and it's not there is no normalization being done over here. So kind of there is an issue. It's not ideal transliteration, so it happens. And the no might not exist in typical Devanagari. So for example, the dot below no might not happen in typical Devanagari. It more suitable for, let's say, Tamil. The two HI token do. So these tokens actually tell you what is the source language and what is the target language. So for example, if you can see this over here, I am a dog S2N. So the way it is done is this will be your input sentence. This will be the end of sentence marker. And this will be the indicator of your source language. So essentially 2EN indicates that this is a sentence in English. Now, what does the 2HI mean? The 2HI will be over here. It is corresponding to what is known as the decoder start token ID. So the decoder start token ID essentially tells the model what is the target language that I want to start generating into. So over here, I am setting the decoder start token ID as 2HI, which means I want the model to generate content in Hindi language. So essentially, that's what it means. Well, Sudarshan is doing a good job of answering all of my questions. Okay. So over here, I wanted to ask that during fine tuning, do we convert all languages to Devanagari script or yes. So during fine tuning, you convert all the languages to Devanagari script. And then once you have created your model and you have fine tuned everything, you then perform translation. Your output will still be in Devanagari script. So your final output will have to be a mapping of that Devanagari script back to the original script of whatever language. So essentially, if you used IndicBART, you wanted to fine tune for English to Tamil. So your Tamil data would have to be converted into Devanagari script. You fine tune on this English Devanagari script Tamil. You get a model. Then during testing, you give a sentence in a you give a sentence as input in English, and then your output will be in Devanagari version of Tamil. Then this Devanagari version you convert back into the original Tamil script. I hope that answers your question, Nikhil.
Uh, may I add a supplementary question to what you just explained?
Yes, yes,
Is
yes, yes.
is there a rule-based code that converts Tamil script into Devanagari script and Devanagari script into Tamil script, or is it done by
Yes,
the
yes,
LLM?
yes, yes. No, no, no. It has nothing to do with the MLM. So in the beginning of this tutorial, I had mentioned this thing right over here, the Indic NLP library. Where is this? The Indic NLP library. So Indic NLP library is actually responsible. It contains the mechanics, it contains methods and API calls, which you can set up in order to do this transliteration. And where it's doing the transliteration, just 1 second. Um, 1 second, 1 second. I remember using oh yeah, I do remember this. Yes. So you see over here in this particular block where the input was in Tamil, I initially segmented it, but it gave very bad segmentations. But then I ran this line of code which does the transliteration, and this Unicode Indic transliterator is essentially present from the Indic NLP library. So that is the only way. That is how we convert everything to Devanagari. So if you gave input as something in Devanagari and then you specified Hindi as the input and then Tamil as the output, it would just convert back into Tamil script. Hope that answers the question.
Yes, thanks.
Okay, cool. Okay,
More questions.
and yes, just 1 second. There are more questions. Yeah, Hindi. So, okay. Anand is asking in Tamil and Malayalam differentiation between ku and ku can be important, wondering how it affects. So we didn't actually study the deep impacts of the specific differentiations between the different types of vowels. But according to the rule-based transliteration mechanism between Indian languages, the creator, Anup Kunchkatan, is the one who made that library, and they've made sure to preserve the long and short vowels correctly between different languages, even during script mapping. So it should not have a particular issue. Um, okay, so then the other question by Manoj is one of the issues we face working with Devanagari is the encoding issues. We represent it in IAST in case of Sanskrit. Did you have any issue in the past? I don't know if that is specifically to the machine learning problem or to the tokenization. I don't think I've explicitly experienced this. Maybe we can discuss it a bit later. I'm not confident whether I can answer this question right now. Ashwant asked one more question. They can be answered quite later, but would like to know what you think about the process of converting every script as a Devanagari script, like down to the line. Do you see the process changing? Okay, so I think the reason why we used Devanagari script is because this was made about, let's say, 2 years ago. No, this was made about 3 years ago. And 3 years ago, the amount of monolingual data available for Indian languages was pretty small. So because we had only a small amount of monolingual data and we knew that mapping everything to Devanagari script would enable transfer learning from one language to another, that is the only reason why we did this approach. At a later point of time, when we have a lot more data for a lot of languages, like for example, recently we have the Indic LLM benchmark, which has the Sangraha dataset, which contains more than 250 billion tokens. Maybe script conversion might not be completely necessary. So it might change and we might not to need to deal with this. But at a smaller scale, yes, this is a good idea. Now, the rules for transliteration had to be manually coded, or is there any automatically way to extract them? So it's in the library. Everything is there in the library. It's manually coded. Anand is asking, I've also observed many words with common Sanskrit roots would have different popular meanings. In Hindi, like shiksha would be punishment, Malayalam is saying, would that mess up the embeddings? Yes and no, but depending on, so you don't train the model just on singular words. You train models on sentences. Because you train models on sentences, based on the context, the model will be able to have a different representation. Maybe one would want to take the IndicBART model and do an analysis of the representation. And then finally, the question is, this is a bit off topic, though, does AI4Bharat have a model or library for? Yes, it is off topic, but the answer is yes. You can take a look on the library. All right, so I'm going to continue this. I hope that is all the questions. No, there is one more. So this is the last question I'm going to take for a bit, and then we'll move on to other questions. Um, recently there was a paper named Roman Setu. Yes, I'm one of the co-authors. Will that be a good to convert all? Oh yes, you should definitely try this Roman Setu logic. It's pretty interesting that you can somehow use Roman script and still work for Indian languages with even models like Llama and even Gemma and so on. So it's something that you should try to uh, yeah, definitely read the paper. It's a very interesting finding that we had. And final vocab size, well, for for IndicBART, our vocab size was 64,000 tokens, and this covered 11 Indian languages and English. But that's all the questions I'll take for now. I'll move on with the notebook. So let's translate some sentences. So the previous model finished training for 500 steps. So let's see what the output is. Okay, so I am a dog is being translated correctly to my kutta hu, I am human, my insan hu, and let us sleep to hum sote hai. So it actually is doing a good job. Just within 500 steps of training, it is able to do some basic translations. I'm pretty sure if I gave it longer and more complex sentences, it would do somehow bad job. But hey, look at it. Within 500 steps, within 5 minutes of training on a Google Colab notebook, you are able to get the model to perform basic translation. If you didn't have this pre-trained model, you would actually need a lot more data and a lot more time to get to these basic translation capabilities. So it means pre-training is really, really being helpful over here. So um, you might want to know how you would be able to, once you've done this fine tuning, right? So this particular block of text, it told you how to do the training, how to give the model, do the forward pass, do the backward pass, compute loss, and so on and so forth. So you've trained this model. How would you save such a model? Well, you'd first create this checkpoint dictionary, which would save the model parameters, the optimizer parameters, and the scheduler information. Um, and then essentially, once you run this, it saves the model as a .pt or a PyTorch object. And essentially, yeah, it's now saved. You can load it at any point of time. If you wanted to distribute a Hugging Face compatible checkpoint, then essentially you would have to make the model in a very specific format, like so. Essentially, you save the model config, you save the tokenizer, and then you save the specific model state dictionary as a PyTorch model.bin. So this creates it into a Hugging Face compatible checkpoint. And then this IndicBART FT is the fine-tuned version of our model. It's a folder. The folder contains tokenizer information, configuration information, and the model itself, which is PyTorch model.bin. Now, if you just load it, it will load very successfully. And then let's see if the loaded model works. Yes, it does. So essentially now this model that you've created, you essentially can upload it on Hugging Face and anyone can use this model without any issues. So it's a very simple, straightforward thing. All you have to do is save in a specific format, and these two blocks of text essentially tell you how to do it. It's very straightforward. All right. So now we've done machine translation, but how can summarization be done, right? So let's first try an existing model for summarization. So at AI4Bharat, we had trained the IndicBART Excel sum summarization model. So it was IndicBART fine-tuned on the Excel sum dataset. The Excel sum dataset is a summarization dataset for a variety of languages. And then we have, let's run it. Okay, so it just loads everything. Just give it a little bit of time. Okay, so now the input is going to be a Hindi, let's say more or less a document. It's a very, very, very long document, uh, as you can see. And our goal is that we want to summarize it. So essentially, as is the case, we do tokenization, we set the model in eval mode, we move the model to GPU, we move the input tokenized version to the GPU, and we ask the model to perform a generation. We use beam search, set a maximum length of 60. These are some standard hyperparameters which are used for summarization, nothing particularly unusual here. And then once the model runs, so this was the input document, and then this is this predicted summary, which is London Dhamako ke mare gaye logo ki suchi jari. So this entire document was talking about certain blasts that took place in London, and then that there was an investigation by the police, blah, 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 blah. You can take a look at this document a little bit later, but it kind of succinctly summarizes the document. So essentially, just as you fine tune the model for English as the input and Hindi as the translation, you could fine tune the model on a document as the input and a summary as the output. And you could get your very shiny summarization model. All you have to do is just change the data in some of the previous blocks. Now, you don't want to use any kind of pre-trained summarization model. How do you actually train it? Again, I'm going to just get some very, very, very simple data for summarization. And for some reason, I am unable to access this particular data set. So I'm not going to be able to run this specific block of code. So that kind of makes it annoying. But the overall flow is the same. You download the data in source target format. You set up the optimizer, you set up the scheduler. And just as before, as we trained for machine translation, we are going to do this for summarization. So essentially, the story is the same. You just change the data format from input as documents, outputs as summaries, and then it goes through 500 steps. And then after that, you have a summarization model. But note that summarization is a very subjective thing. Some people might consider one summary as correct. Some people might consider another summary as correct. But at the end of the day, it's subjective. So you have to be very careful with evaluation of summarization models. Nevertheless, it is a bit more compute intensive than machine translation. Nevertheless, yeah, the summarization is one interesting challenge. And if you're planning on working on it, I definitely recommend taking a look at the Excel sum data set, or even the Indian languages headline generation or summarization data sets, which we had produced a couple of years ago. Okay, I just wanted to take a look at why this thing was not working. Yeah, for some reason the data is not available. Okay, anyways, that is not something I can control over here. All right, so now we've done machine translation. I've given you kind of an overview of how to do summarization. But what about pre-training itself, right? That's the juice. Everybody wants to know how to do this pre-training. Well, the pre-training is done in a very, very, very simple way. Let us first use the IndicBART model skeleton. And let's initialize this model randomly and see, once we've initialized this randomly model, what happens. So what I did was essentially you load up the tokenizer, you load up the model as is, but this will be a pre-trained model. It will contain some pre-trained weights. We kind of want to reset these weights. So you have model.init weights, it resets the entire model, and then it means we can now start using this model for pre-training. So the input that I'd given to the model was I am a mask, and it for some reason is producing the correct output for some reason. I'm not sure why. Oh, something might have changed. Oh, I see, I see. Model.init weights. Oh, this is a bit of a problem. Okay. If this is supposed to run correctly, okay, is not supposed to work like this. In reality, it should be producing garbage. The reason why it's not working is most likely something changed in the implementation, and init weights is no longer the correct, it's no longer the correct library call to perform model initialization. But never worry, just 1 second. I can do something over here. Config equals to uh, okay, from transformers import config, and then I'm hoping that this works. No, 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 don't cheer me up for live coding. I'm just trying to solve this. Okay, I'm hoping that this works and this is the correct syntax. From config, okay. No, 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 no. So the syntax is probably an issue. Let me see if this works. Oh, no, 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 no. Yes, I am hoping that. Oh, yes, I think it should work. Ah, very nice. Okay, so my input was I am a mask, and as expected, it is generating some gibberish. It is generating some very, very random tokens. All right, so long story short, we have initialized MBART model or an IndicBART model very randomly. And because you gave some input to the model, it is just generating some garbage. So then once again, once the model has been initialized, you define your optimizer and your scheduler in this block. We're going to go over here. And then once we have done that, just as before, when we had done some kind of, we had done um, the fine tuning step for machine translation, we are going to do the same exact thing. Let's do this and en. Oh, yes, perfect, 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 perfect. This is great. Okay, so now what it is essentially trying to do is it is going to perform pre-training for, let's say, English. I'm just taking the case of English. So what it is going to do is it is going to produce parallel sentences. And the examples of parallel sentences would be something like, let me just quickly, an example of data set is I am a, and let's say mask, and the output would be I am a boy. The another example would be I mask, I went to the market. So it will have various instances of parallel data for which the model will be trained. And over here, one such thing is I am a mask, which means only the word mask is being replaced by the word boy. But it could have entire phrases being produced. So the word mask could represent went to the market. So this IndicBART model or this BART model training is going through a phase such that it is going to learn how to predict not just words, but also phrases which have been replaced by mask. So your entire parallel data, entire monolingual data, which is in English sentences or any sentences for any language, it is just going to be replaced with mask at various spans, and then your model will be trained to predict these things. Input will be masked, like spans with mask, and the output will be plain sentences which contain the correct predictions. And essentially, this is how the model is going to keep learning. Now, remember, we are training from scratch, so it is going to take quite some time till the model reaches its peak performance. But initially, as you remember, it was giving some very, very, very random garbage sentences as the output. In fact, it was even throwing some Chinese characters or Japanese characters. But then it is actually throwing something less garbage, and over time, it is going to start producing more reasonable, more logical content. And over time, you will see maybe after 500 steps, maybe after 1000 steps, you will see that the model is actually learning how to perform what is called as denoising. And the whole steps about denoising is that you have noise, which is in the form of masked content, and denoising, which means replacing the masked content or predicting correct sentences in the place of the mask. Um, Okay, so the question is, can you show the change in the code again? Yes, I can show the change in the code. It's very simple. So uh, maybe when I had written this notebook about 2 years ago, the thing that you needed to do was you had to just load the model from pre-train and then call the init weights. But now I just created a config and then created a model from the config. When you create a model from the config, it essentially creates a model from scratch. So actually, this line is not needed anymore. Yep, and that's the minor change. Again, if you look at the more recent, let's say, documentation, it will show that this is indeed the correct way of doing initialization. But back in the day, about 2 to 3 years ago, init weights was one of the ways to do random initialization. So yeah, it's essentially just a small change, and it kind of will fix these things. Okay. Interesting. After 400 steps, the model has actually learned to do something very interesting. So now I am a mask becomes I was a lot. Okay, not the best thing, but it's still following more, it's generating something more reasonable. Now let's take a mask becomes let's a lot. Again, not very great, but it is beginning to know what this denoising task is. And if you run this on, let's say, hundreds of millions of sentences on several dozens, maybe let's say 48 GPUs, which is what I played with 3 years ago, you will be able to come up with your own pre-trained model. There are much more optimized versions of the code. There are more scalable versions of the code. So there is a library called YANMTT, which is what I wrote for this exact thing. And you can consider this. So just search, one second, let me send it to everyone. Just search this library, YNMTT, and then you should be able to perform your own pre-training. I've given examples, snippets, and so on and so forth in the library. Those, please feel free to take a look at the library. If you have GPUs on your end, you can train your own Indic models. If you don't have GPUs, this stuff can still work on the cloud. You can still use this notebook, change a little bit here and there, and then you can have your own version of, let's say, IndicBART specific. Let's take more questions. Please feel free to ask more questions. So Harshal says, can we use the, what is the question? Can we use the recent Airawat model to generate these translations? How does it compare to IndicBART? I'm guessing the transliteration step is not required here. So the whole idea is, so Harshal, maybe can you elaborate your question a little bit more? Can you maybe speak and elaborate?
Yeah, sure. Good evening. My
Yeah, good
question
evening.
was Eravat, the Hindi instruction tuned model that has been released.
Mhm.
So, like, my question is, how does the prompting based translation compare to the earlier method that we are discussing here, which is IndicBART? Like, is it better than that, or
Oh,
like, are there more challenges
oh,
associated with that?
okay. So let's clarify this one very important thing. You see, these prompting based models, right? They are still not that good compared to very dedicated high quality translation systems. So to be more specific, if you compared Airavat with IndicTrans 2, IndicTrans 2 would win by a massive margin. Why? Because IndicTrans 2 has been optimized specifically for machine translation, whereas Airavat, uh, first of all, Airavat is built on top of. Wait, you're asking about Airavat. Airavat still kind of comes close to IndicTrans 2, but it is still not a dedicated system purely for machine translation. So Airavat would still fail. Remember, Airavat was instruction fine-tuned not just for machine translation, it was instruction fine-tuned for summarization, for question answering, for like 8 or 9 different tasks. So it would do a decent job, but not as good as, let's say, IndicTrans 2, or not as good as if you took IndicBART and then fine-tuned it on a bunch of parallel corpora. I hope that makes sense.
Thank you.
Yeah. Next one is, so basically for pre-training, we have monolingual data for the languages, then we do MLM training. So this is not MLM training, it's called as denoising pre-training. And why is it so MLM is something that is specific to encoder only models, but when it comes to encoder decoder models, we call it denoising. And in MLM, we try to only mask one token. But in case of denoising, you don't mask one token, you can mask phrases, you can mask up to half of a sentence, and so on and so forth. So I hope that answers your question, Nikhil. Okay. As far as the notebook goes, I'll just share the link of the notebook. One sec. Okay. And Ashwant is asking one more question. How do you see this translation tasks model architectures evolving? Because we see legends like Jan LeCun mentioning how auto-regressive models are limiting. Where can one focus on or aspects to improve? Okay. Ashwant, could you maybe elaborate your question a little bit more? I'm not sure what your
Oh,
specific question is.
hi Raj. Good evening.
Yeah. Good
My
evening.
question is, no, the model which you're currently explaining as a BART model is no. I think
Yes.
uh, it has been developed in what 2019 or 2020, and I
Around
think
that time, yes.
around that time, and we see models currently evolving. I see many researchers and many research labs currently focus on auto-regressive models. No, the decoder only models are
Mhm.
being specialized. So how do you see? I mean, currently you are
So,
also
by the
involved in
way,
all this
BART is also an auto-regressive model.
yeah. It is an
BART is also an
auto-regressive model.
auto-regressive model.
It has a decoder part in
Mhm.
it. I'm obviously not declining all that.
Mhm.
But with regards to
Mhm.
Indic languages, again, there are problems with regards to data as well. But also, do you see specific
Yes.
architectures just so that Indic languages, clearly, we can focus more or adapt?
No. So I don't specifically see any dedicated architecture that would come up for Indic languages, because the question is, what change would you make to a model to handle Indic
Yeah.
languages? Because at the end of the day, the
Mm.
model doesn't understand languages per se. It understands some input patterns and it tries to produce output patterns. So one thing that you could do is maybe have uh, when it comes to Indic specific things, right? What could you do? So, if for IndicBART, for example, for Indic Trans 2, what we did was we had script conversion, right? We mapped everything to Devanagari script. So that is a data level manipulation. But at the model level, what manipulation can you do? One example that I could think of is, for example, you want to translate between Indian languages, and Indian languages to Indian languages translation is monotonic, correct? So in this case, maybe we could have something called as a monotonic attention mechanism or monotone translation. So in other words, if you really need to see the entire input sentence to translate the entire input sentence, you might be able to do it one word at a time. Simultaneous translation might become easier between Indic and Indic translation. I'm saying it might be, but not necessarily. You could consider training a special architecture for non-autoregressive translation specific for Indian languages because of this monotone property. So there are some things that you could try out, but at the end of the day, a simple architecture with a lot of data pumped into it would most likely solve 99% of your problems. Does that answer your questions? Do you have anything to follow up?
Follow up. Nothing else. No. Yeah.
Okay.
Thanks.
But I hope you're satisfied with the answer. Maybe it's not
Yeah,
exactly what you're looking
absolutely.
for.
No, I mean,
Okay.
I often also see your tweets about how people just fine tune all these,
Hmm.
models for Indic languages. So that
Hmm.
was a question I wanted to ask. Like, how do you see people even working for Indic languages if they don't get to join
Okay.
all these big research labs?
Right. So here's the thing. With Indic Trans 2, we showed that even if you're not Google, you can still get something that is state of the art and competitive with Google. And mind you, we don't know whether Google has seen the test sets or not. But we know that our models have not seen the test sets. So you don't need to be a really good group, a big group. You just need to be a group that knows exactly the problem that you need to solve, and then design specific methods and choose specific architectures that optimize for your use case. And then you'll be able to get some really good performance.
Okay, thanks a lot.
Yeah, welcome. Okay, so then Sujit is saying, does IndicBART support English to English? Again, IndicBART doesn't do anything other than do denoising pre-training. It has only been pre-trained to predict content in the place of mask tokens and nothing else. So you're going to have to fine tune it on English parallel data to get it to work like that. Have Could you revisit the changes you made? Ah, for code block having embed for code generation. Okay, yeah, I got the link. Okay, cool. All right. So essentially, that was the overview. And actually, the model has finished training quite a bit. So let's see what the pre-training did. So at around, let's say, 700 iterations of training for the input sentence, I am a mask, the output was I am a lot. Well, not the best sentence, but it is a viable translation. So I mask food, it kind of gave a very bad output. And let's take a mask became let's take a lot. Let's take a lot is okay, a reasonable translation. So it's not particularly an issue. So if you did this on a huge amount of data and you did this for a long period of time, you would actually end up with a very good pre-trained model with this denoising capabilities. So you might also be interested in this work called as mixtures of denoisers. Let me just type it out. So mixtures of denoisers came out about maybe 2 years ago, and it is an improved version of this denoising pre-training. So it doesn't do just mask prediction, but it also does sentence completion, and it does long mask prediction, short mask prediction, and so on and so forth. So mixtures of denoisers is something that I've also implemented in my YNMTT toolkit. So if you want to consider, let's say, working on, let's say, a newer version of IndicBART, or develop your own version of BART for your own specific language of interest, definitely feel free to do that. Okay. So this question is there any work being done on domain-specific translations such as biomedical translations? So yes, there is quite a bit of work being done on domain-specific translation. If you go to the workshop on machine translation, there is actually a biomedical translation task which used to be done. I don't know if it's being done this year, but it used to be done almost every year. There is, some work. There's a workshop called IWSLT, which works more on spoken language translation. So there is a lot of domain-specific translation activity that that takes place. You just have to go to specific venues like workshop on machine translation and IWSLT in order to do that. Okay, we have almost finished 1 hour. So now I would kind of want to wrap up, and I'm welcoming any kind of final questions. Please feel free to ask. And
Hi,
I'd
Raj.
prefer if the
Basapraj this
questions are
side.
more. Yes, yes, tell me. Yes.
Yeah, may I speak?
Yeah, please, please.
Yeah, do we have any low resource training and deployment options for IndicBART?
What do you mean by low resource training and deployment options? So, I mean,
Like
when it comes to
quantized
low resource
versions?
training, the IndicBART model is barely 200 million parameters. I don't think you need to go for quantization.
So
It's a
the
very
inference
tiny
will
model.
be all right. That works.
Yeah, the inference is super fast.
Thanks.
Yeah. Anything else? Any other question?
If there are no more questions, I was wondering, Raj, if you could help me remind me rather the difference between encoder decoder and decoder only, which is like BART versus GPT, because I keep forgetting. Those two are similar, but they're not exactly same.
So an encoder decoder model essentially has, I mean, it's as it says, right? In encoder decoder model, you have an encoder to get a. So the encoder has bidirectional attention. Essentially, the future token can look at the past token, the past token can look at the future token. So encoder decoder models were designed specifically for tasks like machine translation, summarization, whereas a decoder only model doesn't need to worry about bidirectional attention or cross attention. It's just one single decoder only model which can handle essentially any task. So choosing an encoder decoder model versus decoder model is a matter of taste. There is no particular reason for one to say I want to choose the decoder model or an encoder decoder model. But essentially the fundamental difference is exactly in the name. It is encoder and decoder or decoder only. That's it. Okay, any resources where I can learn and know more about how to pre-train or fine-tune AI4Bharat and Indic models? So, I mean, this notebook that I just shared is the main resource which you can use to know how to pre-train and fine-tune. But also you can look at the toolkit that I developed, which is YNMTT. So, yeah, please definitely use this. And also how to fine-tune a pre-train and cloud architecture with low resources. So this notebook is running on the cloud, which is the T4 GPU. If you can look over here, it runs on a T4 instance. So it's going to run without any issues. This notebook, if you run it on your own, let's say cloud service, it will work perfectly, no problem. Okay, cool. Any questions I still haven't addressed yet? I know I blazed through quite a bit of the code, but then explaining code line by line is kind of not what I wanted to go for. I wanted to explain things more at a block level or at a conceptual level. Oh, the collab notebook, I already gave the link 2 times, but this is the third time. Okay, I would also like to get an overview of the current open challenges and questions that require upcoming work. Harshul, maybe you can elaborate more can you just come up on audio and ask?
Sure. I mean, in this field of Indic translations and Indic work, what
Mm-hmm.
are the current challenges or the open questions that remain to be answered? So, like as I see it,
Okay.
my question sort of being in the English side, we already have all the, what do we say, models like Llama, and then on top of that you have co-pilots. So, like
Mm-hmm.
compared to that, what stage are we in? So, like we have all these toolkits you mentioned for catering to our languages, but as
Mm-hmm.
the next steps, are we trying to replicate what has already been done on their side? Is it even possible? Do we even have that much data? Or like, what are the steps that we are sort of looking at from a very, what do we say, broad overview, if that makes any sense?
Okay. So let me see if I can break a question into something that I can answer right now. So you're asking me in the context of machine translation only, or are you asking in the case of general purpose natural language generation?
General purpose Indic natural language generation.
I mean, that's, again, as I said, there's a broad open question, right? The main problem is
And
that
then,
we just haven't solved the data problem yet.
okay,
So it would be very nice to invest into the whole, how do we scale up the data? How do we get more data? How do we synthesize more data? So now is the era of this whole synthetic data generation, right? So I've worked on this paper with a student from IIT Bombay on how to create synthetic monolingual data using machine translation. And we actually showed that if you just take English documents, translate them into Hindi, and then use them for pre-training, they work pretty much as well as using Hindi documents that you would have crawled from the web, with the catch that you'd have to filter the synthetic data that you've generated. So there is like kind of an open space over here. There is an open space for curating data sets automatically using existing LMs and so on and so forth. So there is like a bunch of things. And yes, Javed says you've already mentioned a lot of questions. Uh, in like several questions directly in your question. So yeah, there are a lot of open questions over here.
right. Thank you for the session as well. It was really informative.
Yeah,
You're
one
welcome.
question I would like to add on, Raj, that like me being I speak 5 languages, so I have a general set of knowledge in each language. Does does this apply for the models also the same? If we train it individually on each set of language, will it be able to perform
Mm-hmm.
better as a mixture of language like code mixing?
So basically this is the era of multilingualism, right? If you train a model on a lot of languages, it might end up developing some inherent understanding of multilingual representations, and it might have an inherent understanding of code mixing, but it won't know it directly. So for example, if I took IndicBART, right? And if I just started prompting it with some code mix data, it won't be able to do anything. If you take, let's say, Llama 3 and it's has seen a very small amount of Hindi data. But if you start prompting it with code mixing, it won't naturally be able to handle that. But multilingual training is useful in the sense that if you ever wanted to make it do some code mix tasks, if you have a small amount of training data, it would be doing a better job of handling code mixing. So if you train, let's say, one separate model for Hindi, one separate model for English, and then you expected the Hindi model to will do well with English, probably not. But if you trained a single model with Hindi and English and Romanized Hindi and so on and so forth, it might end up actually being able to understand code mixing. So yes, you have to train multilingual models if that is the question that you were asking.
Yeah, like I wanted to know if it works in general, the idea of mixing the like training it on an individual set of languages and then seeing the performance overall.
Yeah. So see, in principle, with low resource languages, don't train individual models. Try to do multilingual models. It kind of saves you a lot of headaches.
Yeah, that answers my question. Thanks, Raj.
Yes. A little noob question. I am new to this ecosystem. Which are the SOTA open models in Indic NLP? Well, Indic NLP is a broad area. I don't know specifically what tasks. If you're talking about summarization, machine translation, sentiment analysis, AI4Bharat does have quite a few models. IndicTrans 2, for example, is one of the best MT open source MT systems that you can use. But yeah, I think you're going to have to do a bit of digging because newer and newer models come up. But in general, you can use a bunch of models from AI4Bharat, which are publicly available. Shout out, tweet, please. To whom?
No, I mean just you keep tweeting
Uh,
about stuff, right? No, nothing serious.
huh. Okay, you want me to shout out to you? Okay, I mean, tag me on Twitter,
No,
then
no,
let's
no,
see what I
no,
can do with it.
no, no, not me, not me. I mean, like we had the session, it was good or whatever you felt.
Oh, yeah,
Like,
yeah, sure, sure, sure. Yeah, that I'm going to do, no problem. And the recording is going to be up there, so don't worry about it. Yeah. So then the question is on the synthetic data bit. I wanted your opinion. If I use TTS to generate synthetic data for Whisper, which is pre-trained uh, on corpus a wide range of audio for Hindi, uh, for say legal jargon, what model will perform better on transcribing, let's say, in yeah, this whole concept of, let's say, generating synthetic audio data for then using for ASR and so on and so forth is, I think, many people are kind of converging onto this for Indian languages. In fact, we have Yasmin with us today. Yasmin, are you here? Oh, she's here. So Yasmin actually had tweeted a couple of days ago on how she used synthetically created data, audio data for speech translation. So I would say there is a reasonable, viable, there is an interesting possibility of synthetically creating audio data to kind of do data augmentation, and then even if you have a small amount of fine tuning data for the specific domain, should be able to do a decent job. I hope that answers your question, Gautam.
Yeah,
It
good.
is an
Thanks a lot.
it is an active area of research. Okay, so I think it's very fascinating.
Got it. Thanks.
Okay, and this is the last question I'll be taking because it's quite late for me. I need to go to bed. So this is just the final question. Rest of the questions you can ask on Discord and I'll try to answer. So Siddharth is saying in the current all the current state-of-the-art LLMs like Claude, GPT 3.5 can generate Indic languages. GPT 4o can speak fluent Indic language. What is the point of in spending time on these? Isn't the problem already solved? Okay, you can say that, but how do you know that these models? So these are all production models. Okay, these production models are trying to solve a general problem. But if you try to start using these models in very, very specific situations, domains, or niches, most of the times it could kind of not do a good job. So here's the thing. You should not be wasting your time training LLMs. You should be trying to solve specific problems. Every LLM, every model that comes out will have a limitation. Your job, if you're going to work in research and if you're not going to go into big tech, should be focusing more on niche problem, things that these models cannot do. And for that, you have to understand what these models can perform. You have to figure out what the errors are, what the mistakes are, identify why these errors are going to take place, and then you'll be able to make a contribution. So this defeatist attitude is not going to help because that by that logic, 10 years ago, Google Translate already used to do a good job in machine translation. So why would anyone else do machine translation? But the thing is, industry and academia work a bit differently. Industry has a different purpose. They'll always have more data, more scale. But the kind of people, what they are trying to do is different. What we are trying to do as researchers is different. So if you want to compete with Google, you're going to have challenges. But you're trying to solve more research problems, research questions. So this GPT and stuff is more engineering and not as much research as you would think. Uh, but there are some fundamental research questions that you can actually ask on top of this, and then that requires you to actually study and understand these models, their limitations, and then you'll be able to make some contribution. Could you please share the name of the paper you mentioned on using machine translation? Oh, that's just the link that Yasmin just shared. So yeah, I hope Siddharth, I kind of maybe answered your question, or at least kind of because the defeatist attitude is not going to help. Yeah, exactly. So as Baswaraj says, these models do lack a lot of cultural references. At the end of the day, we have to bring these models up to speed. They can do general things, but they can't do specific things. And that specific things is where the demand is. And that is where people will actually be using your stuff. So be patient. There is still a lot of stuff to do. If anybody's telling you that AGI is going to come in the next 5 years, it's not. There's still a lot of stuff. Okay, with that, I'd like to end the session. Thank you, everybody, for attending. I think, yeah, we went for 1 hour and 20 minutes. I didn't expect such a huge crowd, but I'm very happy that you asked a lot of questions. And I'll put this video up on YouTube maybe in a few days once I get the recording. So whoever is responsible for sending the recording, please send it to me, and I'll take care of the rest. Thanks a lot. Bye-bye.